Welcome Pioneers to part 5, the final part in this nuclear series. In part 5, we will discuss the resources required in this plutonium process, and we'll also look at packaging water and packaging nitrogen gas. This build requires uranium waste, nitrogen gas, limestone, sulfur, iron ore, raw quartz, coal, copper ore, deuterium ore, bauxite and crude oil. Technically, crude oil is not required, as I am using that to create empty canisters to sink water byproduct of the non-fissile uranium instead of trying to feed it back into the input loop. This is because of unexpected results from using feedback loops. It's more reliable to package it and sink it. The nitrogen gas is coming in via drone as package form. There is one dedicated drone port for the incoming packaged nitrogen gas and another dedicated drone port for the returning empty fluid tanks. Yes, I could return the empty fluid tanks in the same drone port, however that opens up the possibility of a drone getting held up, waiting and possibly causing a shortage in the production line, resulting in no plutonium fuel rods from being made. At this point, there is no uranium waste being received at this facility. It's fully primed, ready to go. To get that uranium waste, we need to deliver the uranium fuel rods to the nuclear power plants that we've set up earlier. When you watch the part 3 video of the nuclear power plant build, you will see in the second part of that video us delivering those uranium fuel rods and the uranium waste being sent off via drone to this location. That's where we'll jump to next, so you can see what happens when the uranium waste arrives. Here it comes, folks. The very, very important uranium waste heading towards the particle accelerator. The particle accelerator requires non-fissile uranium and uranium waste. So that's the first part of it. Those barrels are also going to this non-fissile uranium process, which is happening now, and we will see coming out of here shortly some non-fissile uranium. And that will start up these. Yeah, it takes a while. There obviously needs to buffer that process up, because it requires 25 waste and 100 non-fissile uranium per minute. Now, as I explained earlier, we're making 100 uranium waste per minute at the 10 nuclear power plants, so it will take a while for this process to fire up and happen. There it is, folks, our first production run in the particle accelerator of the plutonium pellets. They are now feeding over in the background, and they will go to the process in front to make the encased plutonium cells. Here we go, folks, look! Our first plutonium fuel rod coming through. There it is, look at that. We definitely knew it got sunk then. We went from like almost, where are we? We went from 9,672 per minute to 316,972 per minute. It's done. We have a minimal waste setup. There we go, folks. We have, out of this whole process, 25 gigawatts of nuclear power with minimal waste. When I say minimal, there's always going to be some waste floating about the chain of production. This is the last video in this nuclear series. There will be blueprints available for the uranium fuel rod process, the nuclear power plant setup, and the plutonium fuel rod process on the Satisfactory Calculator Interactive Map Blueprint section. The spreadsheet will also be available of the entire build process. I hope you've enjoyed this series on the nuclear production process. Thank you very much for watching. Don't forget to check out the Satisfaction Guru website. It has a lot of articles full of tips and tricks to help you get the most out of this wonderful game that is Satisfactory. Thank you.